Assuming the acceleration of an object is modeled by a of t equals -4 cosine of 2t minus 3 sine of 2t for t greater than or equal to 0, find the velocity function v of t, assuming an initial velocity of 3/2 meters per second. Okay? Okay. So the key idea here is if you have position, a position with respect to time, well, that'll just be, I guess, position with respect to time. If you take the derivative with respect to time of that, x prime of t, that will give you velocity with respect to time. And if you take the second derivative of position with respect to time, that will give you acceleration with respect to time. So as a corollary, or something else that can be said with this data, we would also know that velocity of time, velocity with respect to time, taken as a derivative with respect to time, will give you acceleration. So what they give us here is they give us, all right, we have the acceleration and we want to get velocity. So what we do then is we take the integral of acceleration with respect to time, and that gets us back to velocity with respect to time. And then we'll have a constant, which we'll have to find out, but we're given the initial velocity, t equals 0, is velocity will be 3/2 meters per second. So not too bad. Let's go for this. So rewriting acceleration with respect to time, we have -4 cosine of 2t minus 3 sine of 2t. And we'll take the integral with respect to time, both sides. Whoop, little dt right there. And this will equal velocity with respect to time. Okay? So now we just have to remember how to do the derivative of cosine. So let's see here. We have -4. It's going to be sine of 2t divided by 2. And you can figure that out if you want to do it a little bit more explicitly. You do a u substitution where u equals 2t, du equals 2 dt divided by 2, and you do a substitution through that. So now the question is, we need to make sure we get the sign correctly. So if we take the derivative of sine, we get positive cosine. So if we go the opposite direction here, derivative of sine, positive cosine, yep, that works. So this is correct with the -4 cosine of 2t over this. Okay? Minus, then this will be 3 cosine of 2t all over 2. So now this one's probably going to be the opposite then. And right now, I'm just looking at the sign. Is it positive or negative? So the derivative of cosine is going to be positive or negative sign. And the sign will flip. And so we should have an opposite sign between these two. So to do that, we'll have to have a positive. So the integral of sine is negative cosine. So then this will be correct here as well. And from here then, we're going to do a plus c equals velocity with respect to time. Okay? So let's see. Maybe if we can simplify things a little bit. So we'll do 3/2 cosine of 2t minus 2 sine of 2t plus c equals velocity with respect to time. Okay? And we are told that the initial velocity is at t equals 0, we have 3/2 meters per second. Okay? So we can take that data. So we'll say v of 0 equals 3/2 cosine of 0 minus 2 sine of 0 plus c equals 3/2. Okay? Change over to blue. So cosine of 0, that'll be 1. Cosine of 0, that'll be 0. So we're left with 3/2 plus c equals 3/2. C equals 0. Oh, well, that's just darn convenient. Darn convenient. Thank you. Thank you, problem of convenience. So then, velocity with respect to time will equal 3/2 cosine of 2t minus 2 sine of 2t. And that should be our final answer. Let's see, we'll highlight this guy, bring him over, straighten him out slightly, zoom in, and get something purple. Nice. So 3/2 cosine of 2t right there, negative 2 sine of 2t right there, right there. Bam. Answer. Okay, so looking back what we did, we were given acceleration and we were told to find velocity. So the way you convert from acceleration to velocity is you take the integral. If you want to move this way, you take the integral. So integral with respect to t. If you want to move this way, you take the derivative with respect to time. Nope, that looks terrible. There we go. So start with position. You want to get velocity, take the derivative. You have velocity, you want to get acceleration, take the derivative again. You have acceleration, but you want to get to velocity, you take the integral with respect to time. And if you have the velocity and you want to find position, you then take the integral with respect to time. Or if you want to go from acceleration to straight to position, you'll take the integral with respect to time twice. And that's the idea of how you convert between acceleration, velocity, and position. Hope that helped. See you on the next problem.